Screen share ಆಗ್ತಿದ್ಯಾ? Anyone can confirm me? Am I audible? Yeah. So yeah, in the last class we have discussed about ultrasonic sensor, and we have discussed about which one was that? PIR sensor, right? So today we'll look into servo motors, which is used widely in robotic arms and all. So we'll look into that. Do people want me to teach this gas sensor? Today we'll look like first we'll go to this servo motor because it is very useful. Like you guys have seen, right? This thing, robotic arms. Like you will be having some metal thing in your hand. If you move your hand, even the toy hand will move in the same directions. Have you seen that? Anyone? Yes, no? You can unmute and you can speak. Uh, mm, I'm audible, right?
Yeah, bro.
Yeah. So I'll just show you some images so that you'll get some idea. Which one is best? Mm-hmm. Say, okay. Yeah, these are the robotic hands. So you can control these hands by servo motors. Okay, you have to use multiple servo motors. Then you will be having like another like same setup which you will have in your hand, something like this. By like moving your hands, you can control the robotic hand also, something like that. So we'll look into that how to make those things. So first we'll look into basics of servo motor, then go to that. So to control a servo motor, we need a Arduino board. It can also be done by using 555 motors, like 555 sensors, and also by generating the PWM signal. And you can also control by 555, but we'll use Arduino board here. So this is a servo motor which will rotate 0 to 180 degree. Even 360-degree servo motors are available, but here we have only 180-degree servo motor, which can rotate from 0 to 180 degrees. So you can mention the degree of like for what degrees it should rotate. So for that angle, the servo motor will rotate. Okay. So this motor will have 3 pins. You can see here. One is ground, then power, then signal. So as in the last class, we saw for PIR sensor, even it had only 3 pins, name was same, right? Like power, ground, and signal. So here, so same. So power means 5 volts. So I'll connect 5 volts. Fine. So we have powered with the 5 volts, then ground will ground this using some black wire. So I'll connect this to ground. Okay. Now the signal is to control the motor. As I told, servo motor can rotate from 0 to 180 degree. So you have to control things to rotate in particular angle, right? So we have a pin called a signal. So to this signal, you have to pass some like old PWM signal. You should pass PWM signal so that it can rotate for the particular angle which we have mentioned. So connection is very simple, only connecting 3 wires. Two are like power up pins, so powering up them. One is to control, it is a signal pin. You have to send some signal. So here I have given to the pin number 11. You can give to any pin. I've taken pin number 11. So to code this, I'll go to text. Yeah, I'll remove these things. Only two sections I'll keep. Okay, then even I'll remove this thing. So to control servo motor, we have inbuilt libraries from Arduino. So there is, yeah, in this software, if you go some box kind thing, right? If you can see here, okay, just this overlap. Okay, you can see something, a kind of box. If you keep on this, you can see libraries. So here we have libraries for many, like what to say, like keyboard or LCD. We have inbuilt libraries. We can include them and we can use those libraries to control the hardware. So if we see here, we have library for IR remote. We have library for liquid crystal display, LCD display. We have libraries for keypad. This is again LED, neon pixel LED. We have library for servos also, and many other like stepper motor also we have one library. So here to work with servo we can include this library called as servo.h. So to include this you can write #include servo.h as you write in the C programming. The same way, like you write this thing, right? What is that, stdio.h, then conio.h or iostream.h. Those things. So same as that, you will include here also. This is #include servo.h. So you are including libraries of servo. Then we have to declare a variable for servo, right? To declare a variable for servo, from the like header file which we have included, there is function called as servo space the variable name. I'll say it as my servo. Okay, so servo space my servo, this means my servo is a variable. This variable is for servo motors. Okay, to declare a variable you can declare in this form. This thing like servo, s is capital. This comes from the header which we have included. From the servo.h we have this function called as servo. So from there we are using this my servo. Then we'll have position, because like this is a variable. Int, I can use int position. This is to like say the servo to rotate 90° or 180°. uh, if we go to precision we can go like 57°, 52° or something like 31°, whatever it is. So initially I'll keep this like position as 0. Then in the void setup, here we have to set up the pin number, right, to which we have attached the servo. So from the servo library we have something called as servo.attach. Servo.attach. To know all these things, like from where this thing, like to know like header file what and all functions it has, like dot attach. To know those things you can like go to the origin like Arduino website. Last class I have mentioned, right? Arduino.cc. So servo something, you can search similar things. Yeah, servo space Arduino reference. You have some reference here in this website. So if you open this website, okay, I have my issues, my problem. So if you come to this, you can see here you have methods. You have attach method, write microsecond, read method, attached method, and this detach. Yes. Someone responded. Okay, so you have these many methods here. So attach is to like, if you click on this, you can read what is attach. Yeah, so attach the servo variable to a pin. So to declare the pin of the servo, you can use dot attach. They have given, see, servo dot attach a pin. So s is small here. I have to use s as small. Okay. Here we have to use the variable name. I have declared the variable as my servo, right? So I have to use my servo dot attach. So my servo dot attach. The pin number is 11th pin. So I'm attaching my servo to 11th pin. So I'm using the function my servo dot attach 11th pin as it is shown here. See example they have given. So servo, my servo. So my servo is a variable. So they are using my servo dot attach the pin number 9. Here it is given as pin number 9. Okay. So next we have like declared the pin. Oh, sorry. We have declared the pin where the servo is connected. We have powered up the servo. So now it is just like writing. We write digital write, right? So in this we have something called a servo dot write. I'll go back. See, we have write and also write microseconds. So if I go to write, mm, okay. So we have something called a servo dot write and angle. At what angle it should rotate. So yeah, servo dot attach, then servo dot write. So yeah, in the loop we'll write something like it'll to make the servo motor rotate from 0 to 90, from 90 to 180, then again back to 90, and then again back to 0. To write that, I should use the variable that is my servo dot write. Okay, my servo dot write. I'll use the position variable here. So initially the position is 0. So it will rotate. Oh, okay. So it will rotate to 0th position. So next what I should do is I should mention some delay so that it can rotate smoothly. If you directly write, it will be like rotating very fast. Code will go very fast, so you will not see the rotations. So you have to give some delay so that it will move smoothly and also it has enough time to rotate. So I'll give 300 microseconds, that is enough. Then I'll update the position value to 90. So the value of position is 90. So now I'll copy this, paste. So what happens is the value of position is 90 here. So in the next line, what happens? It will write as 90 degree. So you have to mention in degrees, okay? So 90 means 90 degree. So it will rotate for 90 degrees. Then again delay for 300. Then I'll change it to 180. Okay. So after changing to 180, again I have to write the servo to rotate for 180 degree, then again to 90, and finally it should come back to 0, right? So I'll again write this thing. Okay, it is rotating for 90. Now I have to rotate it to 0. So position 0. Yeah, whenever it goes to 0, yeah, it will start from 0, right? So I'll end with this 0. So whenever it comes here, again it will rotate 0, 90 again. So if I run this code, yeah, okay, it is rotating very fast because the delay thing is like very high. I should increase the delay so that it can rotate completely, because in 300 microseconds it is not able to complete the rotation. Before completing it rotation only, there is another signal coming that it should go to some other thing, right? So what I'll make is I'll give 1 second delay so that it can rotate and it can wait for a few seconds. Yeah, so 1000 means 1 second. So yeah, now you can see it went to 90, again 190, sorry, 180. Okay, I'll make it 2 seconds so that I can explain things slowly. So for every 2 seconds, it will change its position from 0 to 90, 90 to 180, again back to 90 and again to 0. So when I start, you can see it is at 0th position. Now it is at 90. It goes to 180. Again, it comes back to 90. Then it goes to again 0. So this process will be repeating. So it will always be rotating to 0 to 180. So it will stop at 90, then back to 180. If I directly write 180, it will go from 0 to 180 in one stretch. It will not take a pause at 90 degrees. So it depends, like we can take pause or do something at any angle. It depends on the application. So here, the servo working is like servo header file and those variables and the functions of the servo are only this much. You can make use for any application using the servo. Any doubts here, Lalit?
No, bro, I got it, bro. Started from 0 to 90, 90 to 180, 180 back to 0.
Yeah, the coding on this are right. It is you understood, right? Only three things to remember. First one is like you have to use servo command and you have to declare the variable. Then you have to set up using dot attach. So dot attach is to declare the pin. Then the third one is writing. So write means you're making it to move. It means the like pin number 11 will get some voltage. With that voltage, it will rotate. It will be a PWM signal. So it will generate a PWM signal as per the position mentioned. So it will rotate those things. So here, like as I mentioned, to make a robotic hand, it is not possible in this way, right? It is continuously rotating. But what we required is whatever angle we move our hand, it should rotate at that angle at any instant of time, right? Yes, right. So here,
We can make, bro, we
yeah,
can make a loop which takes input, like whichever angle our finger is rotating, it'll take that angle as input and it'll rotate in that moment. If you
yeah,
make
yeah,
a
yeah, yeah,
input is
that
that
thing.
first.
Yeah, I should make that thing. So I should take some inputs from the like hand, right? So what component here we use is we'll use potentiometer. You know potentiometer, right? It gives resistance. So by this thing will be in our hand. Potentiometer will be in our hands. So whenever you rotate your hand, right, the potentiometer like rotor, it will be having some rotor thing. It can rotate like this, no? This thing will rotate. So we will be having some metallic kind thing to our hand fixed. Then we'll be keeping the potentiometer in the fixed position wherever it is like rotating. Now, instead of screws, something like that, we can use the potentiometer as the rotating thing for like for the rotation. So we can sense how much angle it is rotating there. Like this can rotate from 0 to like something, right? So we'll take this value from here to here and we will make these values into an angle and we'll give to servo motor so that it can rotate in the same angles like whatever hand is rotating. Yeah, our hand can move more than 180. No, right? It can move yeah, it will not move more than 180. Hmm, yeah, it will be less than 180 only, so not an issue. If it is going more than 180, then the servo will not be able to continue above that angles. We can use 360. There is two types of servo motors. It can rotate up to 360. So this is just 180, so it is only rotating 180. So to connect this, what we'll do is this thing also. Here we have wiper. Wiper means this will have varying resistance. This first terminal and second terminal will have a constant resistance. If you know potentiometer, then it will be easy to understand. So what I'll do is I'll connect positive and negative pins. Okay, so stop. So I'll connect one end of the potentiometer to positive and the other end to the ground. Oh, sorry, ground is here. Yeah. And what I'll do is I will take this thing. This pin will have varying resistance. So I have to read this. I will read this pin and get some value, and I'll map those values to the servo pin. So I've connected to A0 because it is an varying value. It is an analog value. It doesn't have, it will not be having digital. Oh, time is running out so soon. Okay, 10 minutes is left. So yeah, this thing will have varying values, right? If I keep, auto run. Yeah, if I keep here, if I say this is 0, this is 90, and this is 180, so there is varying values in between. So we have to use analog pins, not the digital pin. Digital pin can have 0 or high level. It means 0 or yeah, low or high only. So in the analog, you can have any in between values also. So I'm using analog pin for the potentiometer. Now what I'll do is I have to map the things. So if I go to the servo, we have like a reference thing in this. Yeah, we have examples. One is knob and sweep. We have seen the sweep thing. We have to see the knob thing. Yeah, connections are in this way. Yeah, this is servo. We are giving to here. They have given to pin number 9, and the potentiometer is connected to A0 or any of the digital pins. So next we need something called as, okay, we have to read. Yeah. Okay. So here, so I'll first declare the pins. So I'll make this as something called as int val. Int val. So it is just a variable called as val. Then I'll declare what is this pin mode. Pin mode. Pin number A0, right? So A0 comma input. Yeah, so this is declared as input. So now I have to use, so I'll remove this thing. Yeah, you can use even for loop here. You can I mean for not for this or the general one, like sweeping from, if you see your car windows, like whenever the rain comes, there is a like shield right for the window. It will be rotating from continuously. So to rotate that kind, like continuously from 0 to 180, 180 to 0, like with a certain interval of time, like very slow, very fast, you can use a for loop, iterate it from 0 to 180 with some delay. Like for every degree you will give some like 10 microsecond delay, so 10 millisecond delay, so that it will be rotating very slow. By varying the delays, you can make it rotate very slow, very fast, whatever, it depends on the usage. So here what I'll do, uh, so I have to read the analog values which is coming to this pin, right? So first what I'll do, val is equal to analog read, and analog, sorry, analog read, okay, analog read pin, which was the pin. Okay, I have not declared the pin name. Yeah, I'll declare it like port. I'll declare something called as port, like define as defined port as a not. Yeah, I'll use here port. Yeah, so analog read port, which means it will read the pin port, so it will get the value. So now what I should do, I have to map, like this will be going from 0 to 255 in 8-bit resolution, or 0 to 1023 in 10-bit resolution. So I have to map those value to 0 to 180 degree. You got my point? Like you have to match those both one is having value from 0 to 255, and this servo will have value from 0 to 180. So I have to make 0 to 255 as 0 to 180 degree. So to make that, we have function called as map. So val equal to map. So what all this map takes, we have to see that thing. So map takes the variable. Okay, not here it doesn't have map. Map. Okay, so I'll check what is map function at all. So map takes 1, 2, 3, 4, 5 values. So first one is the variable which we are like using. Where is this thing? Yeah. So val is the variable which we are using. So val, then comma. I have to name which like what all values to be mapped from where to where. So one is will vary from 0 to 1023. So I'm mapping 0 to 1023 as 0, comma 180. Got this? Any doubts here? I think I'll be having the doubts. So what I'm making, the pot will have value from 0 to 1023. It is in 10-bit resolution. If we are using in 10-bit resolution. So this 0 to 1023 is mapped as 0 to 180. So there is some mathematics here that will be handled by the function called as map. So like converting this scale to this scale. So our value will become 0. Like this value, whatever it is coming, it is converted as 0 to 180 by using the map function here. Next, we have to write this to servo, right? So I've declared my servo. Yeah, my servo dot. So my servo dot write. I have to write this val. At that instant of time, whatever val is there, so that value I'll write to the servo motor. So yeah, see, as I rotate this to 90 in between to the potentiometer, it is mapping to 90. If I go to 0, it is going to 0. You can see, right? If I come back, it is coming back. However, I rotate this potentiometer, the servo started rotating according to that. This is how I will use in the robotic arm. This is only one potentiometer, one servo. If you use multiple potentiometer and multiple servos, we can make a robotic hand. So that like whatever you do in your hand, that robotic hand will follow your thing. This potentiometer will be in your hand. This servo will be in your that model, whichever model you'll make, right? In that model, you'll keep the servo motor, and you have to connect this wires. If you use Bluetooth or some modules, right, you can transmit the data wireless, and you can also control wirelessly. In this state, it is not wireless; it is completely wired. This is wired communication. What we are, so your robotic hand and your hand will be connected through wires here. If you use some like Wi-Fi modules, something like that, you can transmit the data, whatever this right val is getting. You can transmit that through Bluetooth or something like that, and you can make it wireless also. Got this, right? Any doubts here?
Bro, why is that 1023?
Yeah, that is like your analog read, right? It will read your data. So it will read from 0 to 1024 in 10-bit resolution. If the microcontroller is 10-bit resolution, then it will read from 0 to 1023. If I write 225, right, I'll check. So like the 5 volts, whatever voltage is there, now it will be divided into so many parts. So your value, whatever your resistance, right, you're giving 5 volts. See, you're giving 5 volts. See, one end you're giving 5 volts and the other end you're grounding. It means from overall, like from year to year, you have a 5 volts, which is getting divided in this potentiometer. Potentiometer means it will give varying resistance, right? Got my point. Potentiometer will make the voltage drop, like from, yeah, uh, if it is 1 kilo ohm potentiometer, and the 5 volt will be like going down. As you increase the potentiometer, the resistance increases, the voltage will drop. So you will read that voltage. So this thing can read the value, and it can give value as 0 to 1024 or 255 in 8-bit resolution. There is something called. So yeah, where is this? So if I give 255, I have to check how is this working. Okay. It's not working now. Okay, it reached 180. If I make here, I think this will go to 0 because mm, yeah, this doesn't work because this is in 10-bit resolution. So I have to use, like, it can weigh a 10-bit resolution in sense, 2 power 10. So 2 power 10 is 1024, but we are starting from 0, right? So it will be like 1023. So potentiometer, that 0 to 5 volts, whatever it is divided into 1023 times. Like your scale will be something 0.01 volt, something like that. Got this thing? You're scaling the 0 to 5 volts into 0 to 1023, and you are reading it. And this value, you are mapping it to 0 to 180 degree in terms of degrees. Got this point? So if it is 0 to 1023, it works fine. See, it is in 0th position, so it is aligning motor to 0th position. So this is the 0th position of it. As I rotate this thing, it will go back. So don't think this is very slow, because you can see the time it is going in like microseconds, like 3.200 something like that. So it will be fast in real time if we use. See, 4 seconds, only 4 seconds has happened, like not even 1 second. See, still now 5 seconds came. So in terms of real time, it will be very fast. It will be like rotating fast as we expect. So this is how you use in robotic arm. Arduino is used in robotic arm. So we have gas sensor. You people want that? People want that to be thought, or you will just check that and will work. Gas sensors. Where is it? It responded. You can speak. Yeah, this is gas sensor. It has 4 pin. Okay, this thing has 4 pin, but in this Tinkercad we have 6 pin sensor actually. If I go search for gas, okay, I should keep in all, then search for gas sensor. Gas. So this is a gas sensor where you can sense the gas. It can sense many different gases also. It depends on sensor which you buy. Yeah, this is the if this is virtual gas. So as this comes, this sensor will generate some value. Wait, I'm not in this project. We'll make a new project. Okay. So yeah. Yeah. So we have learned this PIR sensor and ultrasonic sensor. here we have gas sensor. So the connection is something like this. One side of the thing will be always like positively connected, like plus 5 volts is connected for all the three pins, and gas sensor where is this orange wire, right? So yeah, this is B1. Either you can take A1 or B1. One side should be completely shorted with this thing like power supply 5 volts. And the other side, one side you should take for the sensor reading. Like you have to read that values, right? So I've given to the A naught. It is an analog sensor. So I'm taking it to the analog pins. And one, the middle one to be connected to ground, and also the other one to be connected to the ground. So this is the connection of this, but normally we don't get only this thing, like we have module. So we have only 4 pins. The module will take care of this connections actually. So we have only 4 pins. One will be power, one will be ground. So I don't know why 2 is given. I have not used the sensor at now. I've used in the Tinkercad, but physically I have not used. So I don't know what these pins. I should check. Yeah. Okay. Where is this thing? Yeah. As we uh, as we do coding for other sensor, here also same case. One is going for analog pin, so I'll define one variable that is a naught. Then I have to set up the things. So if I go to gas sensor, so I'm setting that pin. Only one pin is connected to microcontroller. If you see, only this wire is going to microcontroller, and rest all is like plus 5 volts on ground only. So only this pin is left. I have to make it as input. So I'm making this pin mode gas as input. So coding also very simple. Yeah. Eh, Okay, I'll zoom this thing. So coding the gas sensor is very simple. It is connected to analog pin. So I just have to read the analog pin. So I'm using one variable called as gas value to know the value whatever it is giving. So it'll give some value that will be mapped as to 0 to 1024 again. So from analog read gas, I'll get some value. It will be depending on that gas sensor, whatever it is generating, like whatever the gas density it is. So on that, it will generate a value. So I'm printing that value using serial.print, as in the early class I mentioned how the serial.print will work. I'm printing a string called as gas. Then I'm printing in the new line gas value, the value of the gas. Okay. So then I'm writing some conditions. Like for me, if the value goes greater than 150, if the gas value goes greater than 150, then I'm thinking it is danger, because here as the density increases, the value increases. So greater than 150 is danger for me. So I'm making red LED high, light. Okay, there is some light here. I've used light bulb, which we used, right? So here, this is light. This bulb is a light. So I'm making that bulb to glow. Then I'm making the buzzer high. If it is less than 150, I'm making green LED high, then everything low. So only that much is there in this gas sensor. I can show you the. Yeah, it is. 1 second. So many sensors are connected to the same output, so it is bursting out there. Okay, buzzer is glowing continuously because. Okay. Mm-hmm. Some issue with circuit. I should check that. I don't know what I messed up. Where I use the gas sensor. Okay. Okay, we'll do newly only. So think of this. You're getting Lalit. So here is the gas sensor. What I'll do, I'll remove everything for now. I'll remove all these things. Only gas sensor will use. We can use multiple sensor. That is not an issue. So I have to connect one side with positive. So I've connected. I've shorted all the 3 pins. I'm connecting this with positive 5 volt. Then mid one to ground. The last one is to read the value. So I'm connecting to A0. Another one through a resistor, we have to connect this so that it will not damage this thing. So I'm grounding this thing. So I'll change the wire color so that you see this is also ground. This is all red. This to be red. Okay. This to be red. Yeah. So this green thing mean it is like for analog read. So now I have to code this thing.
So we have grounded from where you're taking the input, man,
What input?
of that gas sensor. Gas sensor.
Gas sensor. Okay. Here, when you simulate, right, you'll get a virtual gas. I'll show you.
No, it's 3 points are sorted to 5 volts. Then other one is ground. Then one more is
Yeah.
what?
One is
A1.
analog
Okay.
read.
A0.
Yeah,
Yeah,
A0.
analog. A0.
That thing will generate you the value. As the gas density increases, this voltage will increase. So that thing will read.
Okay.
Yeah. So first what I have to do, define gas. So gas at A0, right? So A0. Then the hash define is completed. Okay, I deleted this thing also. Oh, wait. I'll remove all this thing. I need this two. One is void setup, one is void. I do not delete this thing. Okay, fine. Yeah. So I have these two loops. Before that, I have to do define the things. Define as define gas at A0. Yeah, not. Then setup. So pin mode. This is an input pin. So I've declared as gas. So gas, comma, input. So next, this is done. I have to write some logics for this. First, I'll make one variable where it can store the input value, like whatever it is reading right from the sensor. So I have to make that value to be stored. So what I'll make is int a val, just a val. So what I'll do, val equal to analog read. Analog, I have to analog. I have to read the analog pin, so I have to use analog read. So the pin number is gas. Yeah. Okay. So pin number is gas. Then I have the value. So I'll do some serial monitor thing. So before to do serial monitor, I have to set up the serial monitor. For that, serial dot begin at 19,200 baud rate. Yeah, 9,200, right? Yeah. There is some specific values for the baud rate. You have to use specific value. You cannot give 9,001, something like that. So you have to give the perfect values. Yeah. So serial dot print. So serial dot print, I'll print a string called as gas. So yeah, this will be printing something gas in the serial monitor. Then I'll make serial dot print the value whatever I'm getting. So sorry, not the string. If I give the string, it will print string only. I'll give the variable val, so not the gas val. Yeah. So first we'll run, we'll check what all the maximum value and minimum value we'll get from this sensor so that we can write some conditions. We can like, okay, print ln. I have used print ln, but then why it is coming the same line? Okay, I've used print. So because I've used print, it is only printing in the same line. You can see, right? It is going in one line itself. So which is not readable. So what we'll do is we'll use print ln. So after this value, it will go to the new line. After printing this value, it will go to the new line. So if I run this, you can see it is going something like this in parallel, sorry, horizontal way. It was before it was horizontal, now it is going in vertical. Yeah. So as I take, okay, I'll just put small. Yeah. So now if I get the gas nearby, you can see the value is raising. So highest density, I'm getting some around 363. Yeah, this is the highest value I'm getting. 360, somewhere 360. And the minimum instance, like if I take very far, if I'm taking very far, it is generating 85. If I'm taking very near, it is going around 300. So somewhere here at the beginning, it is 130. So we can estimate like which how much density is harmful, something like that. We can write condition here. If okay, I'll stop this thing. I'll write the condition if val is greater than 200. You can say it is greater than 200. It is danger for me. Sorry, I cannot use semicolon here. Yeah. So now, although, yeah. So if val is greater than 200, I didn't use any output thing, right? So I'll take one LED. I'll use an LED. I'll connect this something directly, or you need a wire. Anything is fine. You can connect directly also. This thing black. Yeah. I connect it to pin number 13. I have to declare the pins. So go to code. Right. Control C. So pin mode, pin number 13, right? I'm not using a variable for this. I'm just writing directly output. So this is an output pin. Next in the void loop, what I'll make is digital, right? Digital. So digital, right? Okay, D is not capital, B is small. Digital, right? Which one? Pin number 13, comma high. I'll use one more LED so that it will show green. So I'm using, you can change the color to green. Yeah. So I'll connect this to this and this to pin number 12. Red wire. Yeah. So same thing, setup is done. Now how to make the green LED to go low. So pin number 12 as low. Okay. So next we have to do else if it is less than that, or okay, if it is very greater than that, or okay, if it is greater than or equal to 1, this will be satisfied. If it is less than that only, we have to make the green LED high and red LED low. So I'll make this as 12 and this is 13. Yeah, done. So if I use LED, we have to use this resistor. If not, the LED burns. I have not used the resistor, just use the resistor also. So you can see the density is very high, 243. So my red LED is glowing, my green LED is off. So if I reduce the density of the gas, see my green LED is glowing, as it reaches above 200, my red LED starts growing, green LED goes off. So this is how you write conditions for sensor. If it is very far also it is green. If the density raise above 200, then only my LED will glow. So this is the application of Arduino and also the gas sensor. You can use Arduino for any sensors. You can make multiple sensors to be connected. You can use for any application. You have to just search for the application, then start using with the Arduino the sensors which is available, and you can make the products. Any doubts here? Lalit, any doubts? Lalit? Mhm. This is the last class actually. The basics of Arduino is only that much. You have to just you can use vibration motor, which you people like have in the mobiles, right? Whenever you use text, sorry, in WhatsApp or whenever you type in the keyboard, it will be vibrating. Whenever you have a call, it will be vibrating, right? This is called as vibration motor. Just connect positive and negative. So connect how you use the LED, you can use this also the same thing. Even the motor, same as LED, you can use. So photoresistors, those are you have to find understand how is the sensor used, then how to interface it with the Arduino, then start doing it. So, yeah, multitasking is possible with the microcontroller, but this thing what I've thought is not multitasking. You cannot do multitasking here. To make multitasking and all, it will be an intermediate, not the basic thing. So for the basics, only so much is done. Yeah, today is the last day, and this is the last session for the basics of all. I'll stop my sharing.